Okay, class, what we're going to go through, this is a presentation from the slides that covered exponential growth. So for the warm-up says, what is the following linear or exponential? So remember, we're mainly looking at the y and seeing what it does as we move left to right. And again, fractions, this is kind of tricky to see. You're not really sure what you're doing or multiplying by, but you can tell 5 times 3 is 15, and you can double check 15 times 3 is 45. And then you could go back and you could actually type this in your calculator, multiply it by 3, and you will see that you do get 5. So this one right here is exponential because it has a multiplying growth factor to it, I guess. And then what we did was we went through and we talked about 50% of 3,000, a little bit of a percent review or a percent lesson. And so many of us, when we say what is 50% of 3,000, we are able to just kind of cut it in half, right? So a lot of kids in class had cut it in half or divide it by 2. So they're dividing by 2 or cut in half is what we're thinking about. But if we think about the dividing by 2, it's the same as multiplying by 1/2 or multiplying by 0.50, right? Because 50% as a decimal is 0.50. So if you in your calculator you took 0.50 times 3,000, you would get an answer of 1,500, right? Kind of refreshing the memory of 0.50 or 0.50 is 50%, just converted into a decimal. And so when we look at this problem, so then we did this problem in our calculators where we had to convert this back to a decimal, right? And the rule of thumb is if you move it, there's a decimal point right here. Here, let me show you. There's a decimal point right here at the end of every number. So you move that 2 spots to the left because that is the same thing as dividing by 100. So if you wanted to, you could also go in your calculator, type in 20 divided by 100, enter, and it'll always give you the answer. In this case, it's going to give you 0.2. And if it gives you a fraction, say it gives you a fraction of 1/5, right? Then you just press control. Control, I don't know the abbreviation for control on your calculator, but control and then plus enter. So you press control enter and that'll turn it into a decimal, and then you'll have your decimal for that piece. So then once you get it to a decimal, 20% is 0.2 times 40, and you would get an answer of 8. Looking at some of these pieces, just to give us practice, like what is 85% as a decimal? If you plug it in your calculator, 85 divided by 100 is 0.85. You get 0.34. And this was a very important one, the 100% as a decimal, right? It's just 1.00 or just 1.0, or you can just write it as just 1, right? 100% of something is you have the whole thing, so one whole. It's no different than if you got 100% on your paper, you got a 10 out of 10, that's 100%. But a lot of us also know that 10 out of 10 is the equivalent to 1. And so that's what we're looking at when we see 100%. And then we keep going through this. We have 1.2. You don't need to put the 0 there. So you have 1.2, you have 5.4. And these two specifically kind of get tricky for kids because they start to see the pattern but they goof it up. Remember, it's got to go 2 spots. So 1, and then, 1, 2. A lot of kids will go 0.4, but we're missing that we have to have a 0.04. Same thing with this guy, 1, 2, put your decimal, you have a 0.012. So it looks goofy, but that is how those percents, when they're small, look as decimals. They're very small decimals because they are very small percents. So if there's a 20% increase in its cost, is it 20% of the original cost? So when we're looking at percent increases, if we say something is, let's just say something is $10, right? It costs $10, and that's going to be 100% of the cost. So if you go to the store and a t-shirt's $10, and it's just, hey, you're going to pay 100% of what we are charging. You're going to pay $10, right? But now if they say, hey, it's $10, and typically, we'd have a percentage off, but since this lesson is on growth, we're going to pretend that they're raising the price for us. And so they're saying, hey, it's $10, but we are going to go up 20%. We're going to increase that by 20%. So here's what is the entire thing. Like, we're paying $10. That represents 100% of what we're paying. That does not go away. But on top of that, we're also going to be increasing it by an additional 20%. So now what we're really paying is, starting at the original, we're really now paying 100% plus the additional 20 that they added to the original, which means we're paying now 120%. And when we take this number and think about the context of our equation of y equals a times b to the exponent x, we have our initial amount, right? So our initial amount in this case would be the $10, and we're going to see a couple of these examples. $10. And now your growth rate, we can't have a percent. We can't have a percent. So when it comes to the growth rate, what we need to do is we need to take that percent and put it as a decimal. So here we would take 120%. You could divide it by 100, and you're going to get 1.20 or just 1.2. So your growth factor here now is 1.2 to the x. All right, let's look at the, we're going to see some more, but here's the official formula that we use. The R doesn't stand for anything specific, just like the A doesn't. They're just variables. But what we're going to do is we're going to add 1 to it every time. So up here, when you saw this 1, that is going to be there to basically hold the value of this 10. Because if you don't have the 1 there and you multiply, so you're going to go 10 times 0.2, right? And you're going to get something that's smaller than 10. And so in this case, you'd find out that it's $2, right? And like, you're not going to pay $2 if they increase the price. What they really did was they increased the price by $2. So it was $10, but then it went up 20%, which in this case was 2. So it gave you a total of $12, which if you typed this equation right here, the 1.12 in your calculator, that's what you would get. This equation right here would produce $12 if x was a 1. So that's just a formula that you're going to be doing. You're always going to add in 1 to whatever the percent is as a decimal. So growth factor versus percents. You're going to see the difference in that. So we'll go here. So when we're looking at this, we have equations that we're going to identify what the initial amounts are. So here we have the initial amount, which is always our A value, which is 200. Then we have our growth, which is our B value right there, which is 1.25. Right? We really were trying to make this one harder than it needed to be yesterday. Growth factor is just what we're going to be multiplying by, what is in that B place value. The percent increase is new. It's a little trickier. So I like to draw this diagram because this represents our 100%. So 0 to 100%. And as we discussed, like that is our 1.0. In this case, it's representing this 1. This 1 right here represents the 100. And for this context, since we're starting with 200, that's our initial. So 200, if we have 100% of what we start with, we have 200. But now what we have is we added this decimal to it, this 0.25. So the way I like to view it is going like this. And then we added a 0.25, which if we convert 0.25 as a decimal, we multiply it times 100. So 0.25 as a decimal is 25%. Right? And if you add these two together, you get 125%, which is 1.25, which is our growth factor. That means our percent increase, if you ignore the 1 and just look at the 0.25, our percent increase is a 25% increase. We are going to increase the price, or whatever this is, by 25% every year or month, whatever this might be, every day. right? That x value can change. You have to be given the context of the problem for it. I'd pause the video, thinking about what we just did, and give this one a shot. What is the initial amount? What's the growth factor? And then try to figure out, using this, what is our percent increase? Go ahead and pause the video and try that. All right, so A, B, right? This is our initial, 1,000 is our initial. Our growth factor is 1.06% increase, right? Picture that little box. You got 0 to 100%. That represents our 1 in the 1.06. So that represents the 1.00, but then we added this 0.06, which is the equivalent of 6%. So now we have 106%. So we went from being at 100% to 106%, so we had a 6% increase on this one. All right, now I think we have kind of an idea. I'm going to have you pause the video on this one. The first year of a charity walk event had an attendance of 500. The attendance Y increases by 5% each year. What would be an equation for this scenario? Pause the video, give it a shot. Okay, y equals a times b to the x. We know that this is our y-intercept, or the initial amount. So in what we're looking at, we're going to go with y equals 500 times a number to the x. We don't know what the x is. We know it's going to represent year, but we don't know how many years. And then it's 5%, right? So again, I'm going to keep showing you this guy. 0 to 100% was that 500. And then we're going to increase it by another 5%, which is going to bring us to a total of 105%. So that's now the rate at which we're going. So it's kind of like the growth rate, but it's as a percent. So our growth rate is really 105%, but we need to make that into a decimal so we can use it in the equation. So we get 1.05. So if you had 1.05, then you rocked it, okay? Compound interest. Same thing. This one you can actually solve it though. In the last problem, we didn't have a value for x. It just said each year. This one, it does give you a value for x, and it's 6 years. So why don't you pause the video, see if you can put this one into an equation. Okay, y equals my initial amount, which is 400. Right, I'll put the original equation over here. 400 times something, and we do actually need to have a value instead of having to put x there, because we usually don't know, so we usually go x, but we do know this is going to be 6 years. That's our time. And when we look at our graph, 0 to 100%, we know that's 400 of it. We're going to increase it by 2%. Which is going to bring us up, this is not proportional, but it's going to bring us up to 102%. 102% as a decimal is 1.02. 1.02. And then we can type this into your calculator. And in fact, I'm sorry, I don't have a calculator on me right now, and I don't remember what this answer was. I believe if you type this in 400 times 1.02, to the 6, I think it's 450 with some change on there. I don't know for sure, but I believe it's somewhere in that neck of the woods. So that would be right. Main thing is if you got this equation right while you paused it, then you're sitting pretty well. So what would a 100% increase look like? This is just an interesting question, right? If you think about this, and again, this picture helped me a lot. You're at 100%. 100% is 5,200. Now you have a 100% increase. You're going to go plus 100%, which is going to bring you to a total of 200%. 200% as a decimal is just 2, right? 2.00, but you don't need those zeros, so this guy right here would just be 2. You're going to double it. 100% increases, you're going to double it every year or every day, whatever X stands for. Okay. Just keep going. We had a couple of things we're going to look at, so I'm going to keep this video going. So that was the end of first day we did it. This is just a couple extra problems. If you still feel like you could benefit some practice, then keep on watching. If you feel like you got it, that's the end. You could stop watching it. Otherwise, there's some more videos here. I'm about 5 minutes through this guy. So write an equation for a painting that increases in value by 3% each year and is valued at $325 right now. What is the worth after 9 years? So I would go ahead and pause the video. And I am going to give that one a shot. And here we go. We'll go through it. Sorry, I'm trying to pull up my Desmos calculator so I can actually get this out. I did not work this out prior. So we have a painting that has an initial value of $325. And we want to know what its worth is after 9 years, so we know we're going to have 9 there. So really the value we need to work on is this 3%. Again, 0 to 100% is the original value. We're going to add 3% to that, so plus 3%. So we're now at 103%, which is 1.03. And so if we type this guy in, let me type it in to check what you had, 1.03 to the 9th. We have $424, and looks like we'd round that to 5 cents would be our total there. Okay, this one is a good talking point. So the exit check we gave, a lot of people were struggling with 3, 2, and 4. Number 1 went okay. 34 is a decimal. You divide it by 100 in your calculator, you get 0.34. But this guy was a struggle, right? Now we have a decimal, we're going to a percent. And so what we need to do, if we are at a decimal going to a percent, then we multiply times 100. So 1.5 times 100, we are going to move it to the right 2 spots, so we actually get 150%. This decimal, this is one of those ones that scared people because it's so small that they feel like they do it wrong, but I would encourage you to put that in your calculator every time. 1.2% divide by 100, you're going to move it 2 spots, 1, 2. What's your decimal? You have 0.012 as a decimal. And this guy really kind of threw some people for a loop here. Write an equation. If a rare coin worth $500 increases in value by 20.2% each year, how much would it be worth after 7 years? Now, what threw people off was this right here. If I think I went 20%, I think you guys all did great. But pause the video. Give that one a shot if you haven't yet. Okay, let's look at this guy. So we have, I think the first part, 500 is our initial. Our growth rate, which is going to go right here, we know it's our 20.2%. And then we know that we're going to have to after 7 years. So let's look at this guy, right? Draw the picture. And I don't think, if you draw the picture every time and get consistent with that, I don't think a whole lot changes. Now you're increasing it by 20.2%. So now what you have is 100% plus 20.2. So you actually get this, for the first time, a weird 120.2%. Instead of it being 120.0, you just have this 0.2. We divide that by 100. So put that in your calculator, divide it by 100. You're going to get 1.202. And it feels wrong because there's more digits than we usually use, right? We haven't seen 3 digits after the decimal point yet. But that is the correct way of doing it, right? That's how you account for this 0.2%. It's a very small percent, but we still have to account for it. So 1.2. I saw a lot of things like 2.02. I saw just 202. I saw different things when we turned those in. So I wanted to make a note as to how you do that one. These ones all went really well. People who got, number 4 wrong here got 4 correct here. And just to show you, this one was y equals, rare coin, $250. And it increases by 15%. That's going to be 1.15 every 4 years. All right, so on that, let's look at let's just do a couple of these. A house increases in value on average 3.5% annually If you buy a house for $144,000, what should it be worth after owning it for 10 years? What is wrong with these equations, right? Both of these were common mistakes that we've seen. So pause the video and first just look at this guy. I guess I can zoom out so you can see the question. Pause the video. What is wrong with this guy right here? Right? If you paused it or if you didn't pause it, I think what you noticed is the initial on both of them is 144,000. So I think we can identify that's right. And the 10 is the same, right? The thing that is changing is the growth rate. Now the growth rate is 3.5. And we also notice that our percent is 3.5. Now when we consider our chart, we're at 100%, which is 144. I just like to put that in there just as a reminder that that's my whole, that's my initial. Then I'm increasing as I add, I'm going to have to go inside it this time, adding 3.5% each time. So that means 100 plus 3.5, I'm going to get 103, oops, sorry about that, 103.5%. And then I need to move that as a decimal, so I'm going over 1, 2, so I need to get 1.035. That should be my growth factor. So you can see this person just left it as the percent. This person changed it, the percent, to a decimal, but they did not account for the 1. They didn't account for the original 100%. That's why they don't have anything right there. So that's the difference between them. And super common mistakes, but also I think something we need to be aware of. On these ones, I won't talk too much. They're very similar to the ones before. You can pause the video, give this one a shot, labeling those parts. Then I'll fill it in. $516, 1.23, and 23%. Next one, go ahead, pause the video if you want the practice on it. This one's a little trickier because we are looking here. So I would maybe think about drawing your box. This one is a little trickier. Go ahead and pause it and try. 18,000, growth factor of 2.4. Percent increase, right? So now we're at 100%. Which is that 1.0. So the way I would approach this one is, okay, I'm at 1.0, but up here I'm at 2.4, which means I had to increase by 1.4 to get there, right? These two combined equals that 2.4 growth factor, which means I went up 140% because now when I add those together, I'm at 240%, which makes sense because that is 240% as decimal is 2.4. So my percent increase here is actually 140%. I'm increasing 100% from where I'm starting, and then I'm also going 40% above that even. So it's a very large growth rate on that one. Okay, last one here. I didn't know there's a third one, but we have 220 growth factor of 1.042. And if we just focus on, let's just take this 0.42, whoops. To get this, we can put it into a percent by multiplying it times 100, and our percent increase would be 4.2%. So I'm trying to short that video up a little bit in case you're watching it. I can answer more on any of these if you have questions. Come see me, study hall, during class, after school, anything you want, shoot me an email. And thank you for watching.